you say?
Yeah. Which is, what is that, formic acid?
Yes, I think so.
Okay. So H2CO. Okay. So we have a carbon is going to have 4 bonds. Okay. So we have a single. We got an O, and the O is going to have. Let's see. O is going to have a single on one side and a single on the other, but then you've got a double and a double, okay? So we can actually form a bond there with the C. 2 bonds, a double bond with the C, okay? And then you can also form with a hydrogen here and a hydrogen here. Now, this looks a little complicated. Let me rewrite it. Let me redraw it. I'm going to do a C here. I'm going to do a double bond to an O. 2 lone pairs on the O, and then you're going to have an H and an H, and that's...
There's the double bond.
Yeah, there's the double bond. Good. That's a single bond. Yeah. Okay. So, so let's go ahead and do it. Let's see. Carbon is... I don't know why I have trouble remembering it. Okay. And oxygen is blue. No, oxygen is red. Just kidding. Okay. So we're going to do a double bond from the oxygen and the carbon. So we've got the carbon is black, and we have our oxygen. Da, 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 dun, 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 dun. Dun.
Hey!
So we got that, all right. And then we have our H, which is going to be white. I knew that. Okay. Okay. I don't know why I can't remember these colors. PSTD. Okay. So now we've got, this is going to be formic acid. Okay. And formic acid, I don't know why I'm thinking.
Is that the ants?
Ants have, yeah, ants. That's what I say. Ants have formic acid.
Like red ants.
This way? Okay, red ants. Red ants, yeah.
Nice.
Have formic acid. Oh, formic acid. Okay. So you notice how the double bond up here. Yeah, this is our latest spaceship.
Yes,
we're
very
gonna
good.
mission to Mars. Hydrogen, carbon, oxygen. Sorry, not nitrogen. Okay. All right. Who's next?
Ooh, my turn. What do I get?
CO2.
Oh, jeez.
Oh, it's so mundane.
It's so boring,
I
and
know.
everybody. Here's CO2, everybody. Okay. All right, I'm going to do CO2, carbon dioxide. Let's see. Here.
Just another greenhouse gas.
Okay.
Grab that.
So, carbon dioxide. 1 carbon, 2 oxygen, so I need to get a black ball and 2 red balls. And let's see what comes of it. Okay? So, I just know from experience I'm going to put the carbon in the middle and try the 2 red balls on the outside. So, I'm going to attach 1 red ball, 1. So there's carbon monoxide. Actually, no, scratch that. Carbon monoxide would have a triple bond. Okay. Now. Okay. And then I got my other. So I got my other red ball here. Oh, beautiful. That's a good call. Good call, Mr. Dixon.
It's a gift.
We all have it. Oh. Okay.
The gift.
Yes. All right, so I'm like, okay, there's CO2, but the problem is there's an empty hole here, an empty hole here. That can't happen. That means there's an electron here and an electron here that want to hook up, so they're going to bond. Well, guess what? We can do that. Now we got a double bond with this carbon and the oxygen. And, oh, but carbon's still not happy. He still has 1 more lone electron. Oxygen over here still has 1 more lone electron, so let's plug that up. And CO2. Okay. So it's a carbon in the middle, double bonded to, on one side to 1 oxygen, on the other side to another oxygen. Let me show it. Now, let me put it on the board. So it'd be C. All right. And we can do it this way. Right. Okay, so you can see carbon will bond here and then form a double bond here so that they're happy. And then the oxygen over here. All right, we'll have a, whoops, let's put this in. Nah, I don't know. All right, so these two would hook up and these two would hook up, okay? So you have a double bond here, a double bond here, and it eventually looks like this when you're all said and done. There you go. Okay, so there is your CO2 drawing. All right.
Cool.
All right. Oh, oops. Show it up close. There you go. There's carbon dioxide.
Great.
All right.
COCl2.
Oh yeah.
Okay. COCl2. COCl2. I'm going to do this one with the way that I show it for the more complicated ones. Just you count up all the valence electrons and do all that. So this is 7 times 2 is 14, 6, and 4. And you get 24 electrons. And then the first step would be to do your skeleton drawing. And remember, you just put, just connect them all with 1 each. And
Do you do the honk rule? The honk
yeah,
rule?
yeah. So is that the electronegativity thing?
No, just hydrogen would have 1 bond, oxygen has 2, nitrogen 3.
Oh yeah,
carbon
no.
4.
This one I do, and then we do the calculation on that. So the more electronegative element is happier with the lone pairs, so that's why it's on the outside, where it's the less electronegative. So we got 2, 4, 6 we've used up, right? That means there's what, 18 left? So 2.
Okay, it's a stupid thing that says that you can only record for like a half an hour or something. It's some sort of a, for the,
Are we recording now?
yeah, it's recording.
Yes, we
It's
are.
recording.
Oh.
Yeah, you can only record like half an hour at a time,
Okay.
or something, or maybe it's 40 minutes.
So we're going to try to build this. We're going to put carbon in the middle, oxygen. Notice it's double bonded, and that's good because oxygen, remember, has the 2 holes here. So go ahead and put 2 of the flimsy electrons or pairs. There is our double bond, almost carbon monoxide. And then chlorine. Got 2 chlorines. It's the green ones here.
You got your colors down, Mr. Nixon.
Well, you know, some of us. I studied for the test. Okay, so here we go.
Look at that beauty. Yeah.
Carbon double bonded to oxygen, and then the 2 chlorines there. Right on.
Okay.
Next.
C2H2.
Oh, that's,
that's
a
a
fun
good one, yeah.
Yeah.
Yeah, okay, so that one is going to be
It's explosive.
C2H2, yeah. So C is going to have, okay, so Mr. Dixon,
I didn't do it.
I guess he doesn't use the honk rule, but I use the honk rule.
Oh.
So the honk rule says that hydrogen is going to have one bond, oxygen is
2.
going to have 2, nitrogen is going to have 3, and carbon is going to have 4. Now
Honk.
that, sometimes it doesn't work. Honk, honk, honk,
Yes.
honk. Okay. If you just remember that.
It was the original spelling of honk with the C instead of a K that threw me
Oh,
off.
that's what
Yeah.
threw you off.
I was like, where's the K come in?
So
That was
what
some
I'm
guy
going to do
named
is
Honk.
I'm going to make I like Mr. Dixon's idea about doing a skeleton. Okay. So I do this, but I know that hydrogen can only have 1 bond. So that means hydrogen can't be in the middle. Okay, and there's no way. I mean, how could I do hydrogen in the middle? Because it'd have to have 2 bonds. We can't have 2 bonds. So I'm going to put my carbons in the middle and have the H's on the coming out of it, which would make sense because they both have 1 bond. Okay.
One and done.
That means now each of the carbons, though, only has 1, 2, 3, 4. 1, 2, 3, 4. Okay, this has those, this has those. So they're both missing 4 more electrons. Well, carbon doesn't like to have lone pairs. You don't want to do something like that on a carbon, okay? It wants to have 4 bonds, okay? So how could I do that? Let's think, okay? So what if I do a double bond in the middle, okay? that would almost work. Now I have 6 bonds, so 6 electrons, 3 bonds, 6 electrons, 3 bonds. But I'm not quite there yet, so let's do one more. And do I have 4 bonds? I do have 4 bonds. 1, 2, 3, 4. This has 1, 2, 3, 4. So this counts those. This counts those. And they both have octets, and the hydrogens both have duets, and that's what it would look like. Okay? So there you go. That's the honk rule. If that helps, if that floats your boat, then go for it. Okay? All right. So what we're going to do is we've got our hydrogen is white. Okay. So I'm going to get a white one, and I'm going to do. Whoops. I'm sorry. What am I doing here?
That for the 2 carbons.
Yeah. So I'm going to put a hydrogen on here. Okay. And then I'm going to use my other carbon. And I'm going to have a triple bond, so this is going to look kind of interesting. Okay. Okay, this is a model of the mothership. Okay. Here we go. Okay. All right. God, that's really. All right.
Very strange molecule.
Yeah. Okay. So that is going to be C2H2, which is
Acetylene.
acetylene.
It's a common name.
Acetylene, yeah. Acetylene is a common name, but it's also known as ethane.
Ethene.
Ethene.
No,
ethine.
ethine.
Ethine with
Yes,
a Y.
there you go.
But of course, you don't need to know that. We would get into that
Right.
if in a more advanced class. Okay. So, do you see?
Yeah, right there is good.
Okay.
Bring it down just a little bit.
Oh,
There you go.
Sputnik.
In my former life, at the gas company, we used to make that stuff. That's what they use for welding and stuff.
Oh.
Every year, there's at least 1 or 2 acetylene plants that blow up in the United States.
Wow.
Our turn was about 15 years ago in St. Louis.
And you never hear about them, though.
Well, yeah.
I mean, maybe.
Well, you do locally. 'Cause,
Yeah.
Hey, what happened to the old acetylene plant? I don't know. And the thing is, too, they make it by reacting calcium carbonate.
Yeah, I think it's calcium.
With water,
chloride.
so you can't put it out with water. So they basically just, all right, let's let it burn.
Just maybe
Yeah.
put sand or something over
Yeah,
it.
they just stand back and. Sorry, go ahead.
Okay.
Where's Springfield?
The old fire is still going.
Oh, now we're gonna do ethene.
The last one,
Ethene.
we're going to do what is called ethene
Ethene.
in organic chemistry circles, but you guys will know it as simply C2H4. C2H4. So I think I'm going to try that honk rule thing. All right, so you got 2 carbons and then 4 white balls, right? 4 hydrogens. I like that. So, as Mr. Iwan stated, since hydrogen only wants 1 bond, which is 2 electrons, right? You can't be in the middle. So, I'm going to try putting the 2 C's next to each other. And then just, 2 hydrogens on each side, right? See what happens there. Okay, so I'm going to attach, and right, according to the honk rule, carbon being the last guy wants 4 sticks in it. Right? So, let's just do this. All right, and then just follow the little game plan there. Right. Okay, and then, okay. All right, so here's my C2H4, the only problem is, well, let's draw it real quick. All right, we got this. All right, so those H's are happy, right? They got their 1 bond. Okay, these H's are happy. Okay, so that's what I have at the moment. But according to the honk rule, carbon wants 4, right? This carbon has 3 sticks or 3 bonds, right? This carbon has 3, so can't do anything with the hydrogen, so let's just put another one in there. And that gives it a double bond. And you got 4 around the carbon here, and you got 4 around the carbon there as far as bonds, right? Meaning 4 bonds, meaning 8 electrons. So I'm gonna show that, do the double bond. Look at that,
Oh, that's cool.
that's beauty, that's a beauty. There's,
It's an automobile. I don't know. I see an automobile.
I see
yeah,
a horse.
What?
A horse.
yeah.
Horse.
What, kids, what did you see? In fact, let's make that a quiz. Tell me what you see here. It's interesting, it's almost like a Star Wars thing. I don't know, like a
Yeah.
double TIE fighter. TIE fighters were the ones, oh no, that was X-Wing.
X-wing. There you go.
Or,
X-wing were the good guys.
oh no, I'm saying double
Bad
TIE
guys.
fighter. The ones that went,
Yeah.
AT-AT. Was it an AT-AT? Is that
No,
what
that's
it
the
Oh, the
like the
X-
giant elephant mechanical.
okay, so we
is?
got
I
a
don't know
good,
why it's not focusing terribly well.
oh,
Let me see.
okay,
What's
so
the
we-
problem with that?
One of the other things that these models show is that those double bonds are fixed in place.
oh.
So you notice how like it doesn't, you can't really twist it. And that's true in real life as well. Whereas if you had just that single bonded one, this would be a different chemical at that point. But these single bonded ones, they can rotate in space. So the double bonds do actually fix it in space. That's called isomers. Ooh. Okay, who's next?
Okay, well, we're
Is
at
that
the
it?
point.
That's it?
Those are the
Oh.
standard ones. Now, the instructions say, using the model kit, build 2 new molecules and draw them. Make sure the balls have all the holes filled and all the bonds are attached. Make sure your drawings have all the right amount of unshared pairs and of electrons added. So these last 2, the students would have at it. They would just create their own molecule. And there's
Let's do
no wrong answer as long as all the holes are filled.
Let's do it.
And I got mine in mind, but
Oh,
I already know what it's gonna be.
I know what I'm gonna
Okay,
do something with that that whole stereoisomer thing.
awesome. I'm gonna keep it simple. Watch this.
I'm doing pure carbon.
This is it. Oh, wait a minute. Oh, I know what I was doing.
This is not okay. There.
All right, so I'm the first one. Doesn't mean
You're the
anything.
best.
That's right. Thank you. He said it. He said it. Thank you, Mr. Dixon. Okay, look at that. Look at that beauty right there. I put 3 oxygens together. Okay. Now this molecule really exists. Okay. All the holes are filled. This is O3, right? 3 oxygens, and otherwise known as ozone, right?
Not frozone.
Not frozone, ozone. But look at that. So that's,
No, frozone. Pixar.
and I'm going to draw it on the board. Okay, so my ozone. Ozone.
Frozone was Samuel L. Jackson, Oyster.
Yeah.
Not a big Pixar fan.
I just didn't see it.
Yeah.
Okay, so ozone's O3, and it does exist, right? And if you draw it, you can draw it like this. Yeah. Right, and you can see that each oxygen that had its 2 unshared electrons are being shared. And of course, you know, oxygens all have 4 unshared pairs, so, right? I'm sorry, 2 unshared pairs, right? Here we go, this, this, and that. And there's ozone, okay? And if you look carefully, you can see.
No. You did the same one.
How did you get the
How
same
did you do
one
the
I
same
got?
one?
Look at that.
Okay,
you
actually,
cheated.
that's okay. You'll do that, and then I'll do this one, and I'll explain the difference.
Excuse me, gentlemen.
Oh, sorry.
You see this oxygen has 2, 4, 6, 8, so he's happy. This oxygen has 2, 4, 6, 8, he's happy. This oxygen has 2, 4, 6, 8, so as long as they're happy. And ozone. Okay. What did
Very
you guys
rare.
come up with?
I came up with. Well, Mr. Dixon and I both came
Uh-oh.
up with the same one.
But different isomers.
But does Mr. Dixon know
Oh,
what it's
yes.
called?
Well, it would be dichloro, cis dichloro.
You guys are getting
Ethene.
deep.
Ethene.
Ethene.
Yep.
Yeah, good, good.
And then I'll do
The reason
trans.
it's cis is because
It
the
is.
the two are up
Same
up
side.
here. Okay, same side.
Yeah.
Okay. So, and Mr. Dixon is going to show you trans.
Trans.
A trans molecule.
Because they're on opposite sides.
Right. You got it?
So these are isomers. Notice they would have the exact same chemical formula, right?
Right.
But because these are, again, because the double bonds don't rotate, they would actually stay in this configuration, which means they would be different chemical. They'd have different properties.
Right. Every little thing makes a difference.
And a lot of biologically active stuff, a lot of biologically active chemicals have that handedness, right? The isomers.
Right.
And so that's where, yeah,
Yes.
gets very interesting.
Okay. All right. Well, I guess is that it?
I think so.
I think.
Did you wanna-
Yeah. No, I'm good.
There you go. That's it. Thank you
All
for
right,
watching.
everybody.
Thank you
So
all.
thanks for watching, and hopefully that give you a little bit deeper understanding on how these molecules form.
All right. Okay, that's it.
Edit.
Okay, that's it.
Edit.
I